Hello and welcome to Chapter 11, Section 9. Today we are solving radical equations. We're going to take all of the skills that we already have about solving equations and we're going to throw some radicals in it. When a variable is in a radical is when it can get tricky. We've already dealt with this somewhat, so this isn't going to be anything mind-shattering, but here we have to actually solve stuff, which means there's equal signs. So if we decide that the square root of x equals 8 and we want to solve for x, we have to get x by itself. And right now x is with a square root sign. So we're actually going to square both sides. And x here equals 64. And luckily it doesn't equal plus or minus 64, it just equals 64. Because if it equaled minus 64, then there would be a negative number under the radical sign, and that would give us an imaginary number. So we're just working with positives here. 6 equals square root of 4x. So we have to start by squaring each side so that we can get 4x alone, and then we divide both sides by 4 so that x equals 9. When you are multiplying and dividing and solving radical equations, there is an issue in that sometimes when you plug x back into the problem to check your work, it doesn't work. That's because sometimes you have to solve things by squaring it, which gets rid of negatives that otherwise would have been in the equation. So I need you to go back and stick the answer back in. Yes, the square root of 64 is 8. That checks. 9 times 4 is 36, and the square root of 36 is 6. Yes, that checks. This sounds silly right now, but I will show you at the end where it's going to catch up with us when this gets more complicated. So please make that part of your practice. So pause here and check it out number 1 and come back when you're done. For 1a, the square root of x equals 6, so x equals 36. For b, we squared both sides and divided each side by 27, and x equals 3. And for c, x equals 1/3. So let's up the ante a little bit by giving us other numbers to play with. So if I want to square both sides of the equation to get the square root sign off of x, I need everything else to be on the other side of the equal sign. So the first thing we're going to do is subtract 3 so that the root x equals 7. Now I can square it so that x equals 49. Here, everything is already there. When I square it, x minus 5 equals 16. I add 5 to both sides so that x equals 21. So now, we're going to take one of these, and we're going to take one of these, and we're going to combine it. So first, I'm going to get rid of this 4, because it's not under the square root sign. So 2x root 2x minus 1 equals 3, and then I'm going to square both sides, so 2x minus 1 equals 9, and then I'm going to add 1, so 2x equals 10, and I'm going to divide by 2, so x equals 5. Now we're going to go back and make sure that all of these work. I'm going to stick 49 back in for x, and so I've got 7 plus 3 is 10, that checks out. I'm going to stick 21 in for x. 21 minus 5 is 16. Square root of 16 is 4. That checks. 5 times 2 is 10. Minus 1 is 9. Square root of 9 is 3. Plus 4 is 7. That checks. Nothing new. We just have to remember the steps. So please pause here. Try check it out number 2. Come back when you're done. So here we added 2 first and then squared. X is 9. Here we squared first and then subtracted 7, so x equals 18. Here we got rid of that 1 first, then we squared, and then we got rid of the 7 and divided to get x equals 3. So now let's deal with what happens when something is multiplied or divided to our root x. So if I have a 3 times root x equals 21, I'm going to divide each side by 3 first. So root x equals 7, and I square both sides, and x equals 49. And like in math, there's always another way to do it. You can actually square both sides. Because this is multiplied to it, you can square both sides before you get rid of that 3. So now you have 9 times x equals 441, and you divide each side by 9, and x equals 49. So let's try both those methods with divide. Here we're going to multiply both sides by 3 first to get rid of this, so that root x equals 15, and now I'm going to square both sides so that x equals 225. Here, if I square this and I square this, then x over 9 equals 25, and I multiply both sides by 9, and x equals 225. So you get to pick your favorites as long as everything is either multiplied or divided by that root x, and you've already dealt with all of the addition and subtraction parts, then you're good. Now we're going to go back and check. 49 stuck in the square root. 3 times 7 is 21, so that works. And 225, square root of that is 15, divided by 3 is 5, so that works. So go ahead and pause here and try check it out number 3 and come back when you're done. So you can either square both sides or divide by 2 first. On this one, you can square both sides or multiply by 4 first. Here you can square both sides or multiply by 5 first. You didn't have to do it both ways, but whatever way you picked, you can follow the logic here. And the next step with solving equations, what happens if there's a square root on both sides? Well, this first one, because the only thing that's there are square roots, I'm just going to square both sides, which means I have x plus 1 equals 3, and I can solve for x very easily. Here, I have square roots on one side and a 0 on the other. If I add root 3x to both sides, then I get root x plus 8 equals root 3x, and I can square both sides now. 8 plus x plus 8 equals 3x, and I want the numbers on one side and the x's on the other, so I'm going to subtract, an x on both sides, so that x equals 8 equals 2x, and now I'm going to divide by 2, so x equals 4. Now we're going to go back through and check. If x is 2, then 2 plus 1 is 3, and the square root of 3 equals the square root of 3. That checks. If x is 4, 4 plus 8 is 12, and 3 times 4 is 12. So I've got the square root of 12 minus the square root of 12 equals 0, and that checks. Try check it out number 4. Pause here, come back when you're done. Here's one where it's easy to just square both sides and get all the x's on the same side and the numbers on the other side, and x equals 2. In this one, I need to get that root 6 on the other side so I can square both sides and get all the numbers on this side, and x equals 11 over 2. And if you have a decimal here, then do 11 over 2 in your calculator and see if that's the decimal that you got. Squaring both sides may result in an extraneous solution, and this is their answer to please always check when you're done. Because sometimes we get an answer where x could equal positive or negative 3, or x equals 2 and negative 1, that kind of thing, but x can't always be negative. And so when you're working with square roots, sometimes that gets mixed up. So this part is to show you that you always need to check your work. So here's square root of 6 minus x equals x. I'm going to square both sides. So 6 minus x equals x squared. So now I've got an x squared and an x and a 6, and I'm going to pull them all over and find a polynomial that I can factor. So I'm going to say plus x and minus 6, and now it equals 0. So I'm going to factor, I want x, and I want, it's going to have a negative at the end, so there's a plus and a minus, and this is going to be 2 and 3, and the 3 is going to be the positive one. So x equals negative 3 or 2, and I'm going to go back and check. Square root of 6 minus negative 3 equals negative 3, and the square root of 6 minus 2 equals 2. So 6 plus 3 is root 9, and so what they're saying is 3 equals negative 3, and that doesn't work. 6 minus 2 is 4, so root 4 is really 2, and 2 equals 2. So this does work. We do have one answer that works, but not both. Here we have 11 plus root 5x equals 6. So I'm going to start by subtracting 11 from both sides, and I'm going to move it over a little. 5x equals negative 5. And now I'm going to square both sides, and I have 5x equals 25, and I'm going to divide by 5. And it looks like I have a happy answer here. But when I go back to plug it in, 11 plus root 5 times 5 equals 6. This is 25, and the square root of it is 5. 11 plus 5 equals 6. No, it doesn't. So this actually has no solution. And it's because back here, our answer, we had to square a negative number. And we don't always see this. So again, they're saying, make sure you always check your work. And now, just like we had perimeter questions when we were adding and subtracting radicals, we're going to have a area question when we're multiplying and dividing radicals. So we want to solve for x, and we want to know what the side length is. 2 answers. So we know that our area is 52 feet squared, which means the side times this side is 52 feet. And so we've got 13 times root x equals 52. So we're going to divide each side by 13, and we're going to get root x equals 4, and we're going to square both sides, so x equals 16. Now we're going to go back because we want the side length, because solving for x equals 16, but solving for the side length, root x equals 4 feet, because the side length is an actual, I need a unit. Okay? These will often have 2 questions, so make sure it doesn't trick you. Pause here and try, check it out, number 6, and come back when you're done. Here we have a rectangle with an area of 15, and we have a side length of root x plus 1. So we're going to multiply that by 5, and we're going to get 15. I divide each side by 5 so that I can square them and subtract that 1, and x equals 8. So we've solved for x. Now I need to solve for the side. So the side is root 8 plus 1, root 9, which is 3, and I want to make sure that that one has my measurement. Okay? Your homework for tonight, the last section is page 851, and you're going to do numbers 42 through 72 every third. Please make sure you ask if you have any questions, and I will see you next time.